In this video, we're going to do an independent t-test. Now, I have called up the data for the first and last of our CLEAR study. The way I did that is I went into File, Recently Used Data, and then I chose the first and last file. So, first things we need to do is we need to select just the records that we want to use in our t-test. And so one of the things I want to do is I want to select cases. So I go to if condition is satisfied and hit if. I want to choose whether I only want to include people that are myopic or emmetropic. And that's an either or an or situation. And so I'm going to use parentheses. And then I am going to say myopic equals 1. And then I want to say or emmetropic equals 1. So this little vertical bar is the emmetrope, or is the or symbol. And then we're going to say emmetropic equals 1. And then I also don't want to look at all the, remember we looked at change, and we want to have the change have a little bit of separation. So we're going to say and. So within our parentheses we have myopic or emmetropic, and then we want to say and again we're going to need parentheses. Now we can either click this symbol or we can type and open it and close parentheses. So I'll just click on that symbol. And change years is greater than or equal to 3. So we've followed them for at least 3. And now in this case, we want it to be and. Before we said or because we wanted myopic or emmetrope. Here we want and. We want it to be greater than 3, greater or equal than 3. And we want change years to be less than, not less than or equal, but to less than 7. So that gives us change years that are 3, 4, 5, or 6. Continue. Now there's a big difference between ethnicities. So what we want to do is we want to calculate our t-test separately for each ethnic group. And so we're going to split our file, and we're going to compare groups by ethnic. All right, now over here you can see the output log. We have, this is computing this filter. There's our myopics and emmetropics and change years. And down here it sorts the cases by ethnic and then splits the file and layers them by ethnic first. So this is all, we're all ready to go. And we can do analyze from this output screen or this data screen. It doesn't really matter. Let's come over here. And so what we want to do is compare means. You can see in this when we compare means, we can just look at means by themselves. We can do a one sample t-test, an independent samples t-test, or a paired samples t-test, or a one-way ANOVA. And for right now, we are going to work on comparing different groups. So the groups cannot overlap. So we're going to look at ethnic. We're going to look at whether or not at baseline and at the last observation, whether or not there was a difference between ethnic categories. And this is an independent t-test. Now, an independent t-test can only look at 2 groups at a time. So we're going to choose ethnic. And I just realized something that is good for you guys to know. I want to compare ethnic groups. So because I want to compare them, I cannot split the file. So we had the data split file. And so we're going to analyze all cases. We're not going to create groups. So this is grayed out. I did that on purpose so you would see this effect. Okay, let's go to Analyze, Compare Means, Independent Samples t-test. All right, we're going to stick ethnic down here. We want to compare, for this first time, we need to, the t-test only compares two groups. We have 4 ethnic categories. So we're going to define groups. Group 1, we're going to call, or we're going to look at Caucasians, which is group 5. And group 2, we're going to look at Asians, which is group 2. And then we want to look at their mean axial length. That was measured first. We highlight over this. We can see that that was the first one. And we can come down here and we see mean axial length last. So let's look at those two. So we've looked at 2 different ones. What are our options? This has options. Every once in a while, options may be useful. In this case, it's given us an option to change the confidence interval percentage if we would want to do that. And it also lets us decide what to do by for missing values. And when it excludes cases by analysis, that means that if first mean axial length was missing, it would do the analysis for the last axial length if it was missing in one of the, if a subject had it. When it excludes list-wise, that means that if an observation has any missing data in the variables you're looking at, it will just drop the entire case. That's usually not what we want to do. So those are the options available with us. Let's hit OK. We're not choosing any of those. We'll go with the default. And let's hit OK. And over here, we get a t-test. I'm going to expand this, maximize this screen so we can see it a little bit better. The independent sample t-test gives you basically 2 blocks, 2 tables of output. One is the group statistics that has the mean, the number of subjects involved, the mean, the standard deviation, and the standard error. We see we had 147 Caucasians for the first, and my label isn't very good. It doesn't print out the variable name. It prints out the value label, and I didn't label them first and last, so I just know because we did first and then last that that's the order that we have. And I did label ethnicity, so I get these 2 groups. So if you don't have your values labeled and you just have the numbers 2, 3, 4, 5, 2 is Caucasian, 3 is African American, 4 is Hispanic, and 5 is Caucasian. Now, down here we have the independent samples t-test. Now, be careful when you see significance. Don't think this is the t-test or even an analysis of variance f-test. This is a test for equality of variance. Assumptions for the t-test are that you have randomly sampled from a population. All the observations are independent. So the person that's Caucasian is not the same as a person that's Asian, and even within the Caucasians, people are only represented once in our list. So they're independent. Another assumption is that they're distributed, the values mean axial length is distributed normally. Now, it's probably not exactly normal, but this is fairly robust. As long as the values are reasonably symmetrical, the t-test will work all right. And finally, there is the assumption that the variances are equal. And this is a test for that. And it's basically the larger variance. So this is the variance is the standard deviation squared. So if you squared that value and you squared that value and you took the bigger one and put it in the numerator and the smaller one in the denominator, that gives you what's called an f-test. And you can look at, the numerator degrees of freedom are the n-1, and the Asian are the denominators n-1. And so we would look at that, we would get a test, look it up in the tables, and see what our significance is. And we can see that the test is not significant. And so we can say that equal variances are assumed because this is not rejected. This null hypothesis is not rejected. And so we can use this line of the t-test. Now, if this was significant, then we would come down and use this second row down here. Equal variances are not assumed. But since they are going to be assumed, we passed our Levene's test. We're going to look at the top one. And the top gives us the t-value, the degrees of freedom, which the degrees of freedom are n1 for Caucasians, and for Asians, -2, because it's -2 because we have two means that we're estimating. And so it's n1 plus n2 minus 2. And here is the p-value, two-tailed p-value, and it's 0.55. And the mean axial length at baseline for Caucasians and Asians was not different. This is the difference. The difference is just this mean over here minus this mean. So it gives us a minus 0.052. Standard error of the difference. The standard error of the difference is the square root of the standard error squared plus the standard error squared, and that's going to be that. And these are the confidence intervals for the mean difference. Notice that the last observation, where the axial length is 24.3 and 23.9 between Caucasians and Asians, that one was in fact significant. The 23.01 and 22.96, those numbers are pretty close. They were not different. But after following for between 3 and 7 years, the Asians' eyes grew longer in this sample. That's how you do a t-test.